Hi guys, so what we're going to do today is we're actually going to look at inverse trig values, which is kind of the opposite process of what we did when we found our exact values. So what we're going to look at, and if you remember, whenever we solved for sine or tangent inverse, that meant we were trying to find an angle, and that's exactly what we're going to do today. But what we're going to look for is the angles that fall in a specific domain, specifically between 0 and 2 pi. And what you'll see over there, that's just two different notations. One of those is inequality notation. The other one is very similar to interval notation like you saw for domain and range in Algebra 2. But both of those mean the same thing. It just means we want to find our answers between 0 and 2 pi, which if you remember, that is the unit circle. So if I start at 0 and I go full the way around, that was my back to 2 pi. Alright, so what we're going to do is something very similar to what you actually saw on your first test when we first started talking about the unit circle. And we're actually going to be working backwards. So what we know is that the sine of an angle is 1/2. That means that the opposite over the hypotenuse of that angle is 1/2. So what we're going to do is we're going to draw a picture that fits that. But because we're looking for a positive 1/2 on the unit circle, we may have to draw this in more than one location. So we know that sine is positive in the first quadrant because everything's positive in the first quadrant. So I'm going to draw my triangle, mark my theta, opposite is 1, hypotenuse is 2, adjacent is √3. So now all I need to do is figure out what theta is. Well, this is a 30, 60, 90 triangle, and across from 1 should be 30. But because this is asking us to find our answers between 0 and 2 pi, I need to convert that to radians, which is pi over 6. Now the only other thing I need to include is that this says I want to find all the values between 0 and 2 pi. 0 and 2 pi is one full circle, so I need to find another quadrant where sine is positive. And if you guys remember, all smarties take calculus, S was where sine was positive. So we know sine is positive in the second quadrant. It also means I have a positive y-coordinate because sine is my y-coordinate. So I draw my triangle over here. 1, 2, and √3. Now my reference angle is still 30 degrees or pi over 6. But now, because it's in the second quadrant, I need to find what that full angle is. So what I need to figure out is if this yellow part that's colored in is pi over 6, and I know that this line over here that I'm going to make pink, if that line is pi, I need to figure out how much it is if I start at 0 and go to that line. Well, if it's pi, if I go all the way around, and I'm just short pi over 6, then the difference there would be 5 pi over 6. And we get that from getting pi with a common denominator. I do 6 pi over 6 minus pi over 6, and that's how I get 5 pi over 6. So these are both correct answers because I want to find all the values between 0 and 2 pi. Alright, now let's look at another one. This one may be a little bit trickier, just because now we're doing cosine inverse, and these values may look a little bit different. So first of all, what we need to notice is that this is cosine inverse of a negative. So I'm looking for the quadrants where cosine is negative. So if I go back to my all smarties take calculus, remember that tells me which functions are positive. So I know cosine is positive in 1 and positive in 4. So if it's negative, I need to find the other two quadrants. Every function is positive in 2 and negative in 2. We just need to figure out which 2 it is. And again, cosine is your x-coordinate, and x's are negative over there on the left side. So I'm going to draw my picture in quadrant 2 and in quadrant 3. Then I'm going to fill in my values. Cosine is adjacent over hypotenuse, so my adjacent is √2, and my hypotenuse is 2. Now this looks a little bit different than what we're used to, but if I did Pythagorean theorem, this ratio would still work out where I get √2. And this makes that a 45, 45, 90 triangle. So my theta value there is 45 degrees, which is pi over 4. But because this is not in the first quadrant, pi over 4 is not my final answer. Because I'm in quadrant 2, I need to figure out if I started at 0 and went all the way to that terminal side, how much did I move? Okay, so again, pi over 4 is that section in between. So in quadrant 2, This is pi minus pi over 4. So with a common denominator, that's 4 pi over 4 minus pi over 4, which is 3 pi over 4. If I go to quadrant 3, my reference angle is still 45. Reference is still 45, but I would start at 0 and go past pi and then go to additional pi over 4. So in quadrant 3, I'm going pi over 4 plus 4 pi over 4, which puts quadrant 3's answer at 5 pi over 4. And again, both of those are correct. Alright, now, for most of these inverse values that we're going to see, a lot of them are going to have two locations where we can draw a triangle. But we need to think, are there always going to be two locations where we can find an inverse? Alright, so give you a second to think about that. Are there always two locations for an inverse? Okay, so if you think of some examples where that may not happen, that it's not always going to have two, so an example of something that won't have two would be the function cosine of x equals 1. Because what we need to think about here, if cosine x equals 1, think about what that means. That means my adjacent over my hypotenuse is 1. I can't draw a triangle that fits that. But I know that's a value, because the maximum value on those graphs was 1. It does touch 1. And if you remember, there's two ways we could solve this. Okay, cosine is my x-coordinate. This is saying my x-coordinate is 1. So again, think back to your unit circle. 1 with an x-coordinate would be this point over here. And that point is 0. Now because it wants my answers between 0 and 2 pi, if you remember the way that interval was written, it had a bracket around 0 and a parenthesis around 2 pi. The parenthesis means it didn't touch 2 pi. So I don't actually include 2 pi if that's the case. I just include 0 here. Alright, now let's look at one more situation. Okay, so a lot of those points that fall on the lines are zeros and are ones. Okay, so cosine x equals 1, that only gave us one solution. But just because it's on the line, is it always going to have just one solution? Okay, so let's look at a couple examples. What about sine inverse of 0? Sine inverse of 0. So we're trying to think of where sine is negative. So what we're trying to think about is where is the y-coordinate 0. So again, think about your unit circle. That means I'm going up a distance of 0. So over here at 0, that would happen. But then also over here at pi, I'm going to have a y-coordinate of 0. Now, if you're struggling with these values, remember there is also that acronym you can use for those border angles. It was OIO, I owe you. O I don't owe, I don't owe you. And that was sine, cosine, tangent, 0, pi over 2, pi, and 3 pi over 2. Now, if you are using this, you need to be very careful and understand what your question is saying. Because this question is saying sine inverse of 0. So that 0 that's right there, that is not the same thing as 0 radians that's on our chart. It's saying at what angle, so our answer is going to be one of those four things. Okay, the 0 that I'm looking for on that chart is this 0 or this 0. So if it's an inverse question, you're using the inside of the chart. Okay, if it's an inverse question, you are using the inside of your chart. Alright, now there actually is one other case with our zeros and our ones that's going to have two solutions, but it's actually not going to be a question that's on our chart or on our quadrant border angles. So this is probably the most frequently missed question that I usually see with our inverses, because people look at their chart and they try and figure it out, but they don't see it. Tangent of x is equal to 1. Okay, now remember what tangent is. Okay, tangent's the ratio of the opposite over the adjacent. Is it possible to draw a triangle with an opposite of 1 and adjacent of 1? Okay, yes, and we know that that's going to be a 45, 45, 90 triangle. Remember, there wasn't a maximum or minimum value for tangent. It could be anything we wanted. So tangent x equals 1, we actually can draw a triangle for that. Okay, we actually can draw a triangle for that one. Alright, so let's fill in our triangle. Again, I'm looking for where tangent is positive. So tangent is positive in quadrant 1, because they all are. That makes my reference here 45, which is pi over 4. Then I also can look at quadrant 3, because all smarties take calculus. Tangent is also positive in quadrant 3. So again, my reference angle here is 45, which is pi over 4. This line is pi. I'm going past pi to pi over 4, so it's pi plus pi over 4. So it's 4 pi over 4 plus pi over 4, which is 5 pi over 4. So those are my two answers. Alright, so this is the beginning of what we're going to start looking at for inverse values. So remember, we're trying to find every place within one full rotation of that unit circle where these values will exist. Okay, sometimes we'll be able to draw triangles, but sometimes they're going to fall on the lines, and if they're on the lines, we can't draw a triangle. So just keep that in mind when you're trying to figure these out.